Alright, hello everyone, my name is Timothy Lee Grant. So today I am going to be attempting to do this number 33 search in rotated sorted array. So in the morning today I looked at kind of the concept of how to do this problem. So if I'm unable to solve this problem, that looks even worse on me. So let's kind of see if I'm able to solve it. I'll try to I hope I do. Anyways, so the idea of this is we have a list here, and there's some pivot point. So, for example, normally the sorted list would go 0, 1, 2, and then 0, 1, 2, 4, 5, 6, 7, right? In ascending order. So this is rotated. It took the array that was 0, 1, 2, 4, 5, 6, 7, and then shifted it, and then took those and put them on the other side. So likewise with this one, 1, 2, or 0, 1, 2, 4, 5, 6, 7, that's the exact same thing as right there. This one is just 1, okay. So there's one pivot in there. And then we're trying to find the target value and trying to do it in O of n time. So O of log n time. It would be pretty easy to do it in O of n time, but we want log n. So now that indicates binary search. So awesome, let's do that. And the when I was watching the video in the morning, I remember the key concept is that if you look at your bounds, you are able to determine where the pivot occurs. Because if you have your midpoint, okay, and you have your ending point, if your midpoint is lower than your left point, your start, then you know that the pivot occurred somewhere in this region and not the other region. Okay? Likewise, if your mid point here is higher than your ending point, your right point, then you know that the pivot occurred in this location, right? This location, not the other one. Okay, so I can determine where the pivot occurs based off of the ending point. So I look at my mid, and then based off the midpoint and the ending point, or the starting point, I'm able to determine if the pivot occurred between the interval of start to mid or mid to end. Okay, now that gives me information about what I want to cut. Okay, so the way that I'm trying to conceptualize these binary search problems is each time I'm doing something, how can I cut half of the numbers in my array? So I'm going to start writing kind of the while loop and see what I can think of. So left equals 0, right, I'm just going to say r equals length of nums, okay, and then this one is going to be left. So this gives the number of elements, but I want the index. So this is going to be at the last index. So while left is less than right, okay, my question here is going to be, do I want to check when they're equal to each other? And I do, because I need to check that if they go into the middle, right? Well, they're pointing at the same value. I need to check that value if it's the target. But then once they cross, then I know, no, we don't need that. Or that's the stopping condition. Okay, so what do I want to do? If, oh no, I need to find mid. So mid is going to be equal to left plus right integer division 2. Now, if nums of mid is equal to target, okay, what can we do? We can return, and what does it even want us to return? The index, right? Okay, come on. Return the index of target. Okay. So, I can do return m, because that's equal to the target. Okay. Now, if it's not equal to the target, I need to figure out, okay, so mid is here. And it is, I'm just going to take a case. Okay, let's just say if nums of m is greater than target. So, I'm thinking, do I want to check this condition first, or do I want to check where the pivot occurs? Okay, so what would this mean? So, nums of m, my midpoint, is greater than my target. So I want something smaller, right? So what am I throwing away? That's what I need to think about. What am I throwing away? Normally, it would be the interval between m and the ending point. Okay? So I need to check what? If there's no pivot in that region, I can throw it away and I'm good. So if, and how do I check if there's a pivot in that interval? It was if nums of m is so I want to check that there isn't a pivot. So if nums of m is smaller than my ending, because then that indicates that it's just a straight line up. If this is true, nums of right, okay, if this is the case, then I want to change my right to be equal to mid minus 1. So I'm cutting off, I'm taking my, here's my mid, here's my starting. I'm taking my, I don't have a third hand, but I'm taking my, that didn't work. And it makes it even more difficult because I see that the camera is actually flipped. Like, for example, this is my right hand, but it appears as if it's my left hand. But okay, so here is, I'll say here's the interval between mid and my ending point. Okay, so I just want to cut that out, and I put, now my ending point is at mid, but minus 1, because we already checked that m does not equal the target, so I don't want to check it again. Okay, so if that's the case, we do that. So in this scenario, we know, so if this is true, it means that the pivot is not in the in this part, in the last part, the last interval, okay? If that's true. If it's not true, then that means that the pivot is in that last interval. And so a smaller value can exist. Smaller value can exist, and I want something that is smaller. LF, or I guess I can just say else, right? Okay. So now I want to say I need to check if this what? I need to check. So, okay, just thinking back, like, does my bounds give me any information? It's going to be something like this. And then maybe like this. Here's my mid, and then it goes down, and then like that. So I need to check if my leftmost, I need to check if my leftmost is greater or smaller than the target, right? So if nums of my ending point is greater than target, that means that I need the interval with the that does have the pivot in it. So I need to change my left. Left is going to be equal to mid plus 1, else the other case, right is going to be equal to mid minus 1, and that's because this will be increasing the entire time because there's no pivot in this one. The pivot's in the other one. So my target is less the ending is bigger. Come on. Okay. So, in this case, nums is, so the midpoint, I'm just going to say the midpoint is too big, right? Is bigger than my target. And now I've determined that the pivot is what did this tell me? I said it. So my midpoint is smaller than my ending point, which means that there is no pivot in that part. And so then I can change it. So then the other side, if the pivot doesn't occur here, the pivot does occur in the first part. Okay, so the pivot does occur in the first part. So now what I want to do, so the pivot is here in the first part, okay? And now wait, if the pivot occurs in the first part, can't I... No. I think I'm still messing something up. So this one indicates my mid... No, I think I was wrong. Hold on. So my mid is smaller than my ending, which means that the pivot occurs in the first part. Yes. Then I do the else statement, which means that that's not the case. So now I know that the pivot occurs here in the second half. Okay. So pivot in second half. Okay. Mid to end. Okay. So it occurs in that part. Now I want to check, and remember that the midpoint is too big. The midpoint is too big. So what do I want to throw away? That's my question. What do I want to throw away? I want to throw away the portion, the section, which... If mid is too big and I'm looking for target, I want to throw away the section like this, okay? So here's my mid right here. And this is, what did I say? The pivot occurs between M and E. So M and E is going to be like this. So something like this, okay? And then like that. Okay, so here's my mid right there. Okay. And here's to the end, and that's where the pivot occurs. Right there. Okay. Now, I said that I'm my target, so the midpoint right there, this is too tall. Too tall. See that? It's too tall. Okay. What does this indicate to me? It could be right here. Or, again, it's kind of weird because it's backwards. Or it could be right there, right? But it's definitely not this one. Okay, so now I need to check this right here, the start. And if the start is bigger than my target, then I know it's right there. I know it's in here. Okay, so I just said that. Let me write it. So if I'm getting rid of these because I don't want to see it, okay? If my what? If my starting nums of L is greater than target, then I want the other side. I want to update left. So left is going to be equal to mid plus 1, and then otherwise, else, right is equal to mid minus 1. Okay, is that the same thing that I did? So it is the same thing that I did here. Okay, so, okay, there we go. So that might, maybe, be the case where this occurs, that our midpoint is too big. We now need to think of the opposite case. If nums of m is less than target, okay? All right. So if this is the case, what do we want to do? It should be the opposite of the first part, right? But I'm going to try to think through it instead. I don't want to just randomly be typing something and then if I get it right, I'm going to be happy and not even look at it, right? Because, oh, it's submit, it worked, and then I'm not even going to look at it. If I get it wrong, then, okay, well, I was just randomly guessing anyways, right? So I need to think about it, not just, let me actually even just go like this. Hold up. Let me do this, like this. Now it forces me to think. Okay. So, nums of m, or so the midpoint is smaller than the target. I'm gonna look at my little graph thing again here and think. So my midpoint here, okay, is lower than my target. So my target is higher. So if the pivot occurs in the first part, or sorry, so I can throw away all of, so if my pivot occurs in this region, right, I can throw away all of that region because all of this region is smaller. Okay, so if nums of m is greater than nums of right, this means that there is a pivot in that part, in the last part, I mean. So what do I want to do? I want to throw away all of the lower part. So left is going to equal mid plus 1. Else, the case that the pivot occurs in this region, right? So if that's the case, the other region, it occurs here. And now I need to do an if-else statement here. So if else, right? If what? If, so I need to now check because my m, my midpoint, is too small. Okay, and I need to determine if, and I know that the pivot occurs, so this means that the pivot occurred, so mid is greater than my end, which means that the pivot occurred in the first part. So this means pivot is between start to mid, okay? It's between here. So now I am looking for the point which is bigger, right? So so that I need to check my ends, right? I know that. That's what I did last time. I checked my ends. So if something bigger, pivot occurred here. And this is all the way up. And here's my mid, and this is all the way up. And so my mid is too small. Okay, so if my end is also too small, then I want the first part. So if nums of right is smaller than target, if that's the case, I need to throw away that part equals mid minus 1. Okay, else I know that the region is going to be in the first half. Wait, no. Okay, so mid goes up this way, and if this is smaller than, and I need bigger than target. And should I put target here or should I put M here? Like, should it be target or M? So let me just keep thinking about it. So the pivot occurs here. So it's and I need what? I need, the midpoint is too small. Midpoint is too small. Okay. So I need something bigger. And the pivot occurred in the first half, so something like this, like ding. Ding. Okay. And this middle point is too small. So I need to check if this ending point is bigger than target. Okay, like this. So I need to check if, so this is too small right there, my midpoint. This part. It's too small, okay? So I need to check at my ending point if this value there is bigger than my target. So if the ending point is larger than my target, so I'm searching for something larger, right? Yeah. So then this should be, I do left, I want to throw away the left is equal to mid plus 1. Otherwise, right is equal to mid minus 1, maybe. And then if this exits, we return negative 1 because we didn't find it. Let's see. I mean, okay. Alright, fine, whatever. Moving forward, how do I improve myself? Something to do with conceptualize. It's difficult because recently I found out that people can actually see things when they like close their eyes. I thought that they were like, I don't know, I thought that they were joking or something like that. Like, you can close your eyes, you don't see anything, it's just black or pink, right? But then they say that they can imagine something and like visualize it. It's like, I thought that they were joking, but I don't think that they are, because I've asked so many people and they're like, wait, what do you mean you can't see something? And so I'm like, wait, what? What do you mean? You see something? And so I'm trying to, like, I can't visualize anything. Although when I dream, I see visuals, right? Like, you can see visuals. So, how do I, is it a visualization thing? And if so, how do I get around that? That's my question. How do I, is it a conceptual thing? Do I just need to think about it more? I'm not sure. Okay, I think what I'm gonna do is end the video here, or maybe I can just look at the solution. I don't know. Okay. Has a few issues. It's not even one. I don't know. Okay, so I guess I'll try to think about this problem more, like, try to, like, yeah, just think, I don't know. Yeah, so just keep studying this problem until I get it, maybe. So I'll be back tomorrow with trying to figure out this problem. So if you want to subscribe, go ahead. If you don't, that's understandable. And have a wonderful rest of the day. My name is Timothy Lee Grant, and goodbye.